All right, let's look in section 15.1, and we'll start out with number 2. And this is a chart, and it's just a matter of reading the chart. And they want to know f of 95, 70. So you go down to 95 and across to 70, and we get 124. Now this number represents the perceived air temperature with that humidity and that temperature, and that actual temperature. So for B, if we do this, we want to find H. So we go backwards. We go down to 90. We go across to 100, and then we go up and see what H is, and that is 60. So the humidity would be 60%. Here we want to find the temperature when the humidity is 50. So here we go to 50, go down to 88, and then read what the temperature was. And here the temperature is 85. So the actual temperature is 85, and the humidity is 88. Now, F of 80H gives us the perceived air temperature when the actual temperature is 80 degrees. And the humidity varies. And same for 100, it gives us the perceived air temperature when the actual temperature is 100 degrees, and the humidity varies. Now if you look in the chart, if you go down to 80 and then across, the humidity varies from 77 to 83. So it only increases 1 degree every time you move over in the chart. That's 10% change in humidity. So it's not changing very rapidly at 80 degrees. But when you get to 100 degrees, the H is going from 99 to 144. So the increase is 5 degrees to 12 degrees for 10% change in humidity. If you read the chart, it goes from 99 to 104, that's 5 degrees. And then at the end, it goes from 132 to 144, that's 12 degrees. So that's changing a lot more rapidly. All right, let's look at number 6. F of 1 is ln of 1 plus 1 is 2 minus 1 is ln of 1, which is 0. F of E1 is ln of E plus 1 minus 1 is ln E, which is 1. So you're taking an ordered pair to a real number. Now the domain, remember for ln, the inside expression has to be positive. Ln is never, you can't take the ln of 0 or a negative number. So the domain is when x plus y is greater than 1. If we sketch that, okay, that's the line y equal 1 plus x or minus x. And we get everything over here for your domain. Now your range, well, ln, the range for ln of anything is all real numbers. So since it's ln, your range is all real numbers. Okay, your domain, your denominator can't be 0. So x can't equal negative 3y, or y can't equal negative x over 3. So if you graph that, you get everything except the line. So the dotted line means you don't include the line. So the domain could be all, if you want to write it specifically, all ordered pairs such that y does not equal negative x over 3, or x does not equal negative 3y. Okay, here you have two problems. Inside the radical, you have to have greater than or equal to 0, and inside the ln, you have to have a positive number. Okay, so if we solve this for x, and put that together, we have x less than or equal to y minus y less than x. So we have all ordered pair for the domain such that this inequality holds and y has to be positive. Because that's going to make, if y is positive, that's going to make y larger than x. When you subtract, you're going to get a positive number. So you do have to have y bigger than 0 there. Okay, in this problem, we want to sketch this. So we want to sketch z equal y. So that's a plane. And this is y and this is z. And y equals z is this line on the diagonal. So we have this plane on the diagonal. That's coming out from the plane on the diagonal, and it includes that line y equals z. Here we have z equal cosine x. So this is going to be the cosine curve in the xz plane. So here's z and here's x. So we have the cosine curve. And we're going to have the plane kind of coming like that. And of course it goes on forever. So it's the cosine curve in the xz plane, but then it's going to spread out. And you can use Maple to draw all these. So here, let's let x be 0. We have z equal 3 minus y squared. That's a parabola in the yz plane. Y equals 0. Get a parabola in the xz plane. And z equals 0. You get a circle in the xy plane. Okay, so we have an upside down parabola, and we have an upside down parabola, and we have a circle. So it's a paraboloid. Okay, one more. Let's try 44. It says draw a contour map. So those are the level curves. Okay, these are circles because we're going to complete the square. And the centers are 0, 1 over 2k, and the radius is 1 over 2k. So if we draw a few of these, when k equals 1, we have the center at 0, a half. The radius is a half. When k is 2, we have 0, 1/4. The radius is 1/4. Okay, if you do a few more, you're going to keep getting circles in here. And let me do a fraction. When k is a half, we're going to get 0, 1. The radius is 1. And then you can do the negatives. These are just going to be symmetric. And the radius is always positive, so we're just going to get these down here being symmetric. So that's not too difficult to see. That's what the contour map is going to look like. Those are the level curves. And in Maple, once you sketch it, you right-click on your image, and it gives you choices on the style. You can go to contour, and then you can turn it around and rotate it to see what the contour map would look like of that function. Okay, I hope this